Good morning, everyone. Today we'll start with our unit 1, which is the basics of transmission lines. These transmission lines are classified into two types based on its conductivity, which is metallic conductor and non-metallic conductor. Coming into the types of transmission lines, there are the three types, which is open wire, cable, and coaxial cable. This open wire is a common type of cable that we see in our day-to-day life, how the transmission lines have been connected from one point to the other. Next, coming on to the parameters, each and every point in the transmission line consists of these four parameters, which is R resistance, L inductance, G conductance, and C capacitance. One main important parameter of this transmission line is its characteristic impedance. This characteristic impedance is the ratio of amplitude of voltage and current of one single wave in the absence of reflection from the other side. So the voltages and current is measured only when there is a single wave that is transmitting from one point to the other in one direction, and in the opposite direction we do not have any reflections. There are two basic type of transmission line structure, which is the T structure and pi structure. This is a simplified structure of our transmission line. As we have seen in the previous slides, the transmission line has four basic parameters, which is R, L, G, and C. So these are the four parameters that we have to find out. As along with this, we have to find out the voltage and current in the sending end as well as in the receiving. So this is we'll be considering one short section for which we'll be calculating all the transmission line parameters. Each and every line in the transmission, each and every point in the transmission line is given in terms of impedance and admittance. This impedance is given in terms of R and L, which is resistance and inductance. So Z is equal to R plus J omega L. The admittance Y is given in terms of conductance and capacitance. So Y is equal to G plus J omega C. So this equation 1 and 2 representing the impedance and admittance is for the entire length of the transmission line. So considering the entire length of the transmission line is very difficult. So we'll be calculating or finding out the antenna parameters for a small portion of the transmission line. Since this small portion only is considered, yeah, the equation 1 and 2 can be rewritten as Z is equal to R plus J omega L into dx. Y is equal to G plus J omega C into dx, where dx represents the smaller portion of the transmission line. So now we have voltage and current also. This voltage drop by using our Ohm's law, we have V is equal to IR. So we have voltage at one point and the voltage at the other point. We have to find out the voltage drop. So V plus dV is the voltage in one end, minus V is the voltage in the other end, is equal to I into R. This R is a term that is our impedance. So V plus dV minus V is equal to I into R plus J omega L dx. By simplifying this equation, we get dV by dx is equal to I plus I into R plus J omega L. We know R plus J omega L represents our impedance. So dV by dx is equal to I into Z. Next, in the same way, we have to calculate the current difference also. So we get di by dx is equal to V into Y. Next, we'll have to differentiate our equation 3 and equation 4 to get the higher order equations. By differentiating our equation 3, we get d squared V divided by dx squared into V is equal to G into J plus J omega C into R plus J omega L into V. This G plus J omega C is our admittance. R plus J omega L is our impedance. In a similar way, we have to differentiate our equation number 5 also. By differentiating, we get d squared I divided by dx squared is equal to G plus J omega C into R plus J omega L into I. So in the previous equations, we have the current and the voltage equations that is being represented in terms of impedance and admittance. So in order to simplify those equations, we are introducing another constant which is called as propagation constant. This propagation constant is is a constant where we involve all the impedance and the admittance terms. This propagation constant is denoted by gamma and it is given as gamma is equal to square root of zy. What is this propagation constant? This propagation constant is the change undergone by the amplitude and phase of the signal that we are transmitting when it propagates from one point to other. So now we have seen what is transmission line, what are the types of transmission line, what are the basic structure of transmission line, its parameters, what is characteristic impedance and propagation constant. So the further derivation will be discussed in the upcoming classes.